Okay, this is where we started yesterday. You should already have this on there. And yesterday we only practiced with a monomial times a binomial. Today we're going to look at when it's a binomial times a binomial. It's really important that you use those words because you're going to hear me say them and I need you to visualize what I'm talking about when I say them. When you're doing a binomial times a binomial, there are multiple ways to do it, okay? I'm going to show you the multiple ways, and I need you to pick which one you like, and then that's the one I want you to use. You with me? I'm not going to say you have to go this way. This is the way you have to do it every time. I'm not going to say that because there's like 3 different ways you could do it, all right? And I'm fine with whatever way you pick. So the first way to do it is what's called the distributive property. Now, this is my favorite way just because it works every time. When we get down to where if we, let's say number 3, if it had been a binomial times a trinomial, the distributive property would work every time. So come up here, we're going to look at this example. We have x minus 1 times x plus 4, right? The distributive property, I call it the split repeat method, all right? Split repeat. You're going to take the first set of parentheses and I want you to draw a slash between the 2 terms, just like we practiced yesterday. Draw a slash between the 2 terms in the first set of parentheses. Did you draw it right? No. Did you draw it right there? Okay. We're going to split them apart. And we're going to write after it a set of blank parentheses. So watch. Just watch me. Split x beep minus 1 beep. Notice how I did that? I'll show you one in just a second. It's called the distributive property. If I distribute papers to the class, what does that mean I'm doing? I'm passing the papers out, right? And everybody gets one, right? The distributive property is the same thing. I'm passing out x to everything over here. I'm passing out -1 to everything in here. Here's where the second step comes, and it's called the repeat step. You're going to repeat the second set of parentheses in the blank parentheses that you had drawn. Now, don't make a judgment call on it yet. This is only the first example, so if this feels a little uncomfortable, it's the very first example. Let me show you another one before you decide, you know what, I don't like that method. So we've just done the split repeat method. We split the first set of parentheses up and we put some parentheses after it, leaving them blank. Then we repeated the second set of parentheses in those blanks. Now, look at the beauty of it. What you've just done by going this route is you've just taken a binomial times a binomial and you've rewritten it into a monomial times a binomial, which is what we did yesterday. So we've just taken what was complicated and we've rewritten it to what we already practiced yesterday. So now you should be able to do this. So if you would try it right now. You're distributing this x into the x plus 4. Then you're distributing this -1 into the x plus 4. Yes. Try it first. Remember, I can teach you better if I have something to work with. If the paper's blank, I have no idea where your mind is. Positive times negative. Yes. So x times x becomes x squared. Yeah, you're thinking of x plus x. That would be 2x. Remember, when you're adding and subtracting, the variables and the exponents don't change. But when you're multiplying, anything goes. So x times x is x squared. X times 4. So this is just a big old number, not an exponent. So they just shove together, and it's 4x. Does that make sense? That's why we're practicing it. It's okay. So x times 4 is 4x. What's negative 1 times x? I heard it. Negative x. Negative 1 times 4. Negative 4. And then, like we were saying yesterday, then you would combine any like terms. So if you look underneath here, this is x squared. Is there any other x squared in there? No. So there's nothing to combine that with. So this just comes down. 4x minus x, are those like terms? They both have just an x, right? So 4x minus x is 3x. And then this minus 4 comes down. Excuse me. Now I want you to make a note over here. I want you to write a bracket, and then sideways I want you to write distributive property. We just did the distributive property. That's one of the methods. The other method is what's called box method. Some people like the box method. The box method helps you to organize your work in a nice little neat box and then get your answer in the end. The box method is also the distributive property. It's just the box helps you to organize your work. Some people struggle with knowing what to write when you just have a blank page. The box method sometimes helps you to know what to put where and when to multiply. So let me show it to you. We're going to do it with number 2. There's not a lot of room here. So try your best to not write big. We'll write it over here. You need to draw a box close to the edge of the paper because we need space to the left and above it. And then you fill the box in based on the number of terms in the parentheses. So the first set of parentheses has how many terms? 2. So I'm going to create 2 columns, which means I just need to draw the one line. The second set of parentheses has how many terms? 2. So I need to create 2 rows. And then above it, we're going to put what we talked about, and left of it, we're going to put what we talked about. So we said 2x plus 3 goes up here, and then 2x minus 3 goes right here. Now, that's setting it up with the box method. Now what you're going to do is multiply by looking at the intersection of the rows and columns. So for instance, and it's really hard to do this on a video if someone was watching it from home, which we're going to have, so I'll highlight. So you're going to multiply this term, you're going to multiply this term with this term, and where they intersect, you're going to put your answer. So 2x times 2x is what? 4x squared. crowded. Now we're going to repeat. I'm going to use the highlighter, so if anyone's watching on the video, 2x times 3, and it's going to go right there. What's 2x times 3? 2x times 3. 6x. You're adding them. It's okay. Remember to multiply. So it would be 6x. And you can put a positive in front of that if you want. You don't have to. Keep going. Negative 3 times 2x. Negative 6x. Negative 3 times 3. Negative 9. Y'all see how I got that? Now here's the beauty of the box method. It lets us organize our multiplication. You're not done here. You still have, this is basically where we are in the box method. We have like terms in there that we have to combine. And they're usually on the diagonal, if there's any. Sometimes there's not, but if there's any, they're going to be on a diagonal. Do you see that? So you go to write your answer. Your leading term should always be the top left corner. And your last term, which most of the time is a constant, should be the bottom right corner. Your stuff in the middle should combine somehow. All right, so let's write it. We have 4x squared. What happens to 6x minus 6x? They cancel completely, which is rare, but they did. And then we have minus 9. Now, we need to talk about this. The reason that those terms in the middle canceled is because this is a special case scenario. There's a name for this. What do you notice about the two sets of parentheses? Tell me what you see. They are alike, but one's addition and one is subtraction, right? Everybody can recognize that. That's called a difference of squares. Here's why it's called that. Remember I said mathematicians, when they named things, they named it in ways to help you remember what it means. A perfect square is something times itself, right? Yes? Perfect squares are when you take something and you multiply it by itself. That's a perfect square. Are these perfect? There's a difference, right? Hear the name? There's a difference in the squares. And that is just that simple sign. So let's make a note. This is called a difference of squares. I need you to know that if you can memorize that vocab word and recognize when you have that in front of you, it makes life easier. Is it a must-know? Not necessarily. You can still survive math without being able to say, oh, that's a difference of squares. But does it make life easier? Yeah, it makes life a lot easier if you can recognize when you have a difference of squares in front of you. And what's going to happen every time you have a difference of squares is that middle term cancels out. Every time. That's the only time the middle term cancels, is if it was a difference of squares. If you go back up here to what we did earlier, nothing canceled out, right? Well, that's because we didn't have a difference of squares. Okay? All right, let's go to number 4. Number 4 is the same thing, but what's changed? There's a trinomial. So you can either do the distributive property or the box method. I'm going to actually show you both. I'm going to change the screen though because I have no room to do both on there. I'm going to show you both of them, and then now I want you to start deciding which one you like. Okay, so I'm going to go to a different screen. This is going to be the distributive property work, and then this is going to be the box method. All right, I'll set you up with the box method in case that's the route you're going, because once I tell you how to set it up, you should be able to finish it. The first expression is how many terms? How many terms is the first expression? Let me write it. We have x to the second power plus 4x plus u. Right? Okay. So we have two terms. So you can either do two columns or two rows. Doesn't matter. That's what it would look like with two columns. Now on your paper you probably don't have a lot of room. So let's do two rows. Now why did I make it so long? What do you think? Because we're fixing to have how many columns? 3. And then you would write it above it. Plus u. Alright, that's the box method. Then you would start multiplying. Here's the distributive property. You take the first set of parentheses and split it. So we have x squared beep, plus 4x. Beep. Then you take the second set of parentheses and you repeat. Because now what you've just done is broken it down into a monomial times a trinomial, which is the same thing you're doing over here. You just have the box to organize that multiplication. So now I want you to try the multiplying. Multiply it out. Try it. Remember, it's like running a play in football. Coach needs to see it before he can make adjustments. I need to see you try it before I can say, ooh, you forgot the negative, or ooh, this is going to add. Oh, you got it? And when you finish trying it, you're welcome to check your answer. It's the cross section, so it's like visualize that these are going to come together here. Okay. Yeah. Well, when you're multiplying terms like this, and you can see like this term and this term, you add the exponents. It's kind of weird. It feels weird. But here's why. Let me show you why that is. So, like, you have x squared times x cubed, right? X squared means there's 2 of them. X cubed means there's 3 of them. How many are there total? So that's why it's x to the 5th. That's called expanded form. If you ever forget when to add or subtract, when to add or multiply the exponents, write it in expanded form, and then it's just a matter of counting. Alright, since I've already made a mess over there, I'm going to do the distributive property over here. So it's going to 3 things, right? So x squared times x cubed is x to the fifth. X squared times 3x squared. What would that mean? X squared times 3x squared. 3x to the fourth. X squared times -1. What'd you get? X squared times -1. -1, you don't have to write 1, you can if you want to. -1x squared, very good. 4x times x cubed. Noel, what'd you get? 4x times x cubed. That's right. Just look right here with me. So you're going to multiply the coefficients, and then you're going to add the exponents. So 4 times 1, 4. They both have an x. This is x to the first power, and then times x to the third power, so x to the fourth power. Alright, 4x times 3x squared, 12x to the third, and 4x times -1, -4x. Might have to take your time combining like terms. We've got x to the fifth that should be in the front. We then need x to the fourth. We have 3 plus 4. When you're adding and subtracting, the exponents don't change. They're like last names to let you know, oh, those two go together, and then those two go together. Then we need to pull the cubed next, so it's in standard form. Then we have the squared, and then we have the leftover. Whoo, that was a humdinger. What? Humdinger. A doozy. It was a lot. A lot of work. All right, tell me where. Because of 4 times 3.
Yeah, 4 times 3 is 12. And then how do you get x?
Because it's x to the first power times x squared, and you add the exponents, so the x cubed. Yep. Now, the last problem on here, we're going to save that for tomorrow. What I'm going to give you is an answer sheet for practice problems, and the practice problems are going to be posted in Google Classroom. I was trying to reduce the amount of paper that I ran off. So you'll just pull up your Chromebook to get the problems, okay? The practice problems are going to cover a little bit of everything, all right? That way you're getting that practice before we take this test. This is going to be graded on completion, although we will be checking to see if you got it right or wrong, because I need to be able to help you if you got it wrong. But if you just finish it, then you will get 100 on it, okay? And like I said, the questions are going to be posted in Google Classroom. We actually only have 3 minutes left, and y'all have done really good today, so I'm going to let you pack up if you want to. But you need to put page 13 on this. This is your practice assignment. I need it done before you come to class tomorrow, because what I want to do tomorrow is help anyone that is still kind of struggling a little bit, also review, and then your test is Friday, okay? Thank y'all so much for being so cooperative and easy to teach.